Assalamu alaikum and adab, dear students. Today we will go through the design of tension members. We'll see how this member is to be designed. First of all, we'll go through the design steps. We'll see the stepwise procedure for the design of this member after a certain condition is given to us. So first of all, we analyze the data given to us. Analyze the data given. So in this, what we need to design the member is first of all the load. This must be axial tensile load. So this data must be provided to us for a particular load. We have to carry out the design of that particular tension member. So this is the load. Then other parameters include the length of member. Length of the tension member must be specified. What is the distance from center to center of intersection of the particular tension member? Then we have the conditions, certain condition, that is the type of member, what structures we are going to use to design this particular member. There may be conditions given, there may be members, structural members conditions, they may be given. Say for example, if we are given that the member should only be a single angle section connected to the gusset plate, this can be one of the conditions. Or else we may be given a double angle section. For the design, we will have to choose a double angle section on the same side of the gusset plate. This is second condition. This may be one of the conditions, this may be second. Or else we may be given two angle sections which are connected to either side of the gusset plate. This is one of the cases. Then it may also be other structural elements, say a flat to be used as a tension member. So this is the flat member to be used, or a channel section to be used as a tension member. So if this member is given, how we have to design, using what structures we have to carry out the design, we'll have to follow that. Plus end connection. End connection detail must be provided to the designer, whether we have to carry out the design using a riveted connection, or there can be a choice of welded connection also. There may be fillet welds provided to connect the member to the gusset plate. So all this data, whatever is given, we'll first of all analyze all this data and sum up how the design is going to proceed. Further, we should now know the yield strength of the particular structural component. Yield stress must be given. If sometimes the yield stress is not given, we may choose an appropriate value for this particular thing. So this is the initial data which is to be provided to us to carry out the design. If some data is missing, we may assume it suitably and proceed with our procedure. Then the second step. Fy is provided or taken by us, assumed by us. We can calculate the permissible tensile stress in the member. That is sigma AT. Sigma AT we can calculate. The sigma AT is 60% of the yield stress. So we know this value in Newton per mm square. Okay, this is the second step. Then we go to, before we select the member, before we get an idea which member is to be selected, we calculate the area requirements. Area of the member should be known to us so that we can select a certain section and then try it whether it will suffice our requirements or not. So we come to net area requirement of the member. In the third step, we calculate the net area of the member, which is equal to the load which the member has to sustain divided by the permissible axial tensile stress. So this will give us the net area of the member. The net area should be equal to or more than this required area then our member will be safe to resist the given load. But steel table does not provide us net area. Steel table always provides us gross area of the member, that is without any sort of deductions. So before we go to the steel table to select a trial section, we calculate the gross area required. So this is A gross. Gross area required, which shall be net area. We will have to enhance this net area by a certain percentage because we actually are not knowing the exact figure this time. So we enhance it by 20% to 40%. We increase the net area by 20 to 40% to calculate the gross area. This is in case of a riveted connection, if rivets are provided for the end connection. If we provide welded connection, then we know that there is not going to be reduction in the area of the holes. There are going to be no holes drilled, so we increase it by 10% only. This will give us a gross required tentatively, so that we get going, we select a section and then we further investigate that safety of that particular section. So once we get the gross area term known to us, we go to the steel table. From the steel table, we select a section as per the conditions given, whether single angle, whether double angle, or channel, or a flat, whatever we have to follow. In respect of that, we select a section from the steel table corresponding to the gross area what we have already obtained. The section what we select, say for example, I have to select ISA some designation. The area of this angle section should be equal to, or it should be more than the gross area required. So whatever member we have to select from the steel table, the gross area of that particular member must be more than or equal to the gross area as per our requirements. This we call a trial section. This is our trial section first. So we'll try whether this section will be sufficient or not. Otherwise, we may have to revise and choose a higher section or even a lower section if it is going to be uneconomical. Then in the next step, in the sixth step, we check the net area of trial section 1. For this particular trial section, we check its net area now, putting it to our conditions. We know whether we are going to use a riveted end connection or a welded connection. As per that, we check this area, this section for the net area available after all sorts of deductions. Say for example, we have taken a single angle section connected to the gusset plate and we have to check its net area. Our condition is that we are going to provide a riveted end connection. So what we'll do, we'll see where this riveted end connection is going to be used, how many rivet lines are going to be used. Accordingly, we'll frame a tentative section. This ISA I have selected from the steel table. This is connected to the gusset plate, and as we did in load carrying capacity, we calculated the net area of the member. So here also we'll calculate the net area of the member as A1 plus K times A2. So we'll see whether this condition falls in case 1 of load carrying capacity, net area calculation of the particular member, or it falls in case 2, or it falls in case 3 as has been discussed while we calculated the load carrying capacity of the particular member. So we'll see our case falls in which category. We'll calculate load carrying capacity for that particular with respect to that particular case, and we'll see that net area calculated here, a net of the particular member, whether this is satisfying our requirements, whether this A net is greater than or it's equal to the net area requirements, that is our area required. If it is so, then our member is safe. If it is not so, say the net area what we have calculated is less than the required net area, A net required. If it is less, then it will be unsafe. Since it was a trial section only, we may go for another section in which the area requirements will be, area to be taken will be higher now. We'll take a section with a higher area for our trial second. We'll continue our trials till the required condition is met, till the net area of the selected member is greater than or equal to our requirements of the net area. Once this is achieved, we will finalize that section what we had selected as a trial one is going to be the adopt. We are going to adopt that particular section now. After that, we'll go for the end connection design. Now, we had earlier decided that we are going to provide, or there was a limitation that we have to provide a riveted end connection. So, we'll accordingly design the end connection. If it is welded end connection, we will have to go for the welded end connection. So, if it is riveted end connection, we'll have to, for a riveted end connection, what we have to calculate, we have to see, say, if I draw the elevation of this particular member, this is the angle section selected. At the ends, it is going to be connected to a gusset plate. So this is the gusset plate. This is ISA. This is the gusset plate. This is the CG. For the end connection, we will have to design the diameter of the rivets. We will have to design the number of rivets. That is, we'll have to calculate the load value, number of rivets, and shall be equal to the total load divided by the rivet value. So this will give us number of rivets rounded off, and we will see the provision, how we are going to arrange these rivets. The rivet lines have to be arranged in such a way that the CG of the rivets provided should match with the CG of the angle section so that there is no eccentricity. So we will calculate number of rivets and see its placement with respect to pitch. We will calculate the pitch required to satisfy the minimum and maximum criteria. This of course shall be the CG, that is CXX distance, which we can obtain from the steel table, number of the rivets and edge distance at both the ends. This will give us the overall overlap. How much overlap is required to be provided so that such end condition is properly designed and implemented. So it may not necessarily be a riveted end connection always. If it is a welded end connection, if we have to provide a welded end connection, so in that we'll have to calculate the effective length of the weld. This is what we have to calculate, the effective length, the length which is required to be provided to meet the load capacity. The weld should resist the load which has been provided, which the tension member has to resist. So this length we'll calculate and then see how it is going to be provided. This length, we'll have the load carrying capacity as overall length, effective length of the weld to be provided, multiplied by the throat thickness of the weld and the permissible stress in the weld. This L, once we obtain this, we'll have to see how this L we are going to provide. So again I draw the front elevation. This is the angle section. Connected to the gusset plate once again. This is the gusset plate. This is our ISA. This is the gusset plate. We know this length. This is the L1, length of one of the legs. If the angle is connected by its longer leg, then L1 will be the longer leg. If the angle is connected to the gusset plate by a shorter leg, by its shorter leg, then L1 will be the length of the shorter leg of that particular ISA. Then, so this length is known to us. We know the total length to be provided. Out of this, say this is L1 is provided, then we will have to calculate these two lengths. Since the angle section is unsymmetrical about x-axis, this L2 and L3 won't be same. They will be different because the CG of the entire length what we are welding, the CG of that particular welded length must coincide with the CG of the member to avoid eccentricities. So L2 and L3 have to be calculated. L1 is known to us. We take the moments about a particular point for all these three weld strengths and ultimately find out this L2 and L3. And the final picture, when we show this, all these dimensions of the tension member design should be given in a proper sketch. This is when a single angle was there. Say for example, I take two angles, then how this I take, if two angles, we had two ISA and the connection was a fillet weld, then how is this going to look like? Say this is one of the angle sections. If it is connected on the same side, another angle section will look here, will appear here. These are the two angle sections. Connection with the gusset plate has to be shown. This is the gusset plate now. So this time we are having two angle sections. This is 2 ISA. This is the gusset plate. Our connection is a fillet weld. So we will be having the total weld length required, or the effective weld length required L. Now our provision will be something like this. This will be L1 now. L1 will include the connecting leg length of the connecting leg for both the angle sections. So that will become our L1. Then here, as was previous one, as we saw in the previous case, we could not provide equal length welds at the top and the bottom because the section was unsymmetrical. But when two unsymmetrical I sections combine together, this is the position of the CG. This is now x-axis, which is centrally located. So this becomes symmetrical when we provide angles on same side of this gusset plate. Hence this L2 and this must be L2 once again. These weld lengths have to be same in such a way that L1 plus 2 times L2. Total length of the weld shall be equal to L1 plus 2 times L2, so that symmetry is also maintained and the design and the required length is provided. So we sum up that in the design of a tension member, we have to look for the data given. The data given has to be analyzed. What sort of member we have to provide, we go by the design of that particular section. Likewise, if some data is missing, we can assume that suitable. Then we select a section, calculate its net area required. But from the steel table, we have gross terms, we have area in gross terms. So we increase it by certain percentage depending upon the end connection to be provided and calculate the gross area of that particular member. After calculating the gross area, we select a trial section from the steel table. For that particular trial section, we draw a figure how this will look like, and whether it falls in case 1, 2, 3 or any other case, we calculate the net area requirement of that particular section. the net area shall be less than or greater than or equal to at least equal to the net area requirements our what we had already projected. So that section, if it is satisfying our requirements, then it's okay. If not, we'll take another trial section. We'll continue till our requirements are met. Then we go for the design of end connection, whether it is a welded end connection or a riveted end connection. Thank you.